All right. So I'm going to start again. This is going to come up over and over and over again, that OSI reference model. How do I memorize OSI reference model? With programmers do not throw sausage pizza away. Programmers do not throw sausage pizza away. And we'll come back to it over and over and over again because this is the way all of our network communications work. Come on. There we go. Go back to where I want to be. So I like this chart as a way to kind of look at and understand what pieces happen where, and to understand that we start with that idea of those zeros and ones starting at that physical layer. They go all the way up to the application layer and then back down. So when we say the TCP/IP stack, well, it's kind of silly because we're really saying transmission control protocol / internet protocol. So anytime we see the word P, I almost always assume in this class that it's protocol. So we go up the stack, we go down the stack. And then along the way, we're manipulating things. So this is one of the harder ones to think about and put on in your brain. Ugh. I will never ask you the extremely technical name. How about that? So that original model, so we take the data, what we want to send. So maybe we've got a video we're going to upload to TikTok. And we're going to take that TikTok video, and so we've got an app on our phone, and it sends it then down to the layer 4, the transport layer. And it breaks it into small enough segments to send, and it puts a header on there. The next layer down, it breaks it again and puts another header, and then we frame it in layer 2. In other words, we put a header and a trailer, and then we send this data out. So this chart may also help you when you start looking through materials and you're trying to figure out, wrap your brain around this, because this is probably the hardest thing we're going to deal with in here. How does it go up? And then we got to remind ourselves that some of these devices are not, they don't go up the full stack. So switches and typically go 2 frame or to layer 2. There are new switches, so when you go out and you decide, hey, I'm going to go buy a switch for my company, you may find one that says, hey, it's layer 3. And it will go up into that network layer and it's got additional functionality. There are ones that go all the way to the application layer and do a lot of things. But they're really expensive. So this is that idea. And then on the far right is really that idea where I start with my payload, and then it becomes a segment, and then I take that piece, becomes the payload for the next layer, and we put another header on it. And then the packet becomes the payload for the frame, and we put a header and a trailer on it. And so if you look, we're putting a lot of little zeros and ones in front and behind. And so we're going to talk about how those interact and what those actually look like. And we'll actually show you with a program the very same signals that are coming in and out of your computers. It is nothing more than a string of zeros and ones. Millions and millions and millions of them. All right, so we went through the real quick safety procedures that are in there. And really for us, the biggest piece is don't get caught somewhere where a fire is going to catch you in a system that's oxygen depleting. We don't have it in this building, but we may have in the admin building or a larger server environment. So we talked about network problems, that detective model. So we really have hit almost everything in chapter 1. And if you've noticed in Blackboard, and I'll show you kind of what we need to make sure you get done, we went through chapter 1 and we're going to start chapter 2. So chapter 1 we have a quiz for it, chapter 2 we don't. So I'll go through and we'll look at that really carefully so we make sure that everybody's on the same page. One of the questions I've gotten is if you go into Blackboard directly or into Cengage, there are a lot of assignments that say need grading and they count towards assignments. Well, the reason I do that is I have a couple of people that are wanting to take the Network Plus exam after this. So I've made everything available that I can possibly make available. Problem is, I can't make it available and not make it as an assignment. So from the Cengage side, it looks like you've got all these things due that we aren't using in here yet. So, and sometimes I will take things out simply because I know that they don't work. So these links, so any link inside of Blackboard, these are the links we need to do. So let me just run through them real quick for everybody. I put in the Chapter 1 PowerPoint. So the preview is really just the objectives. What are we going to do in this chapter? This is your reading link. So then we have some clips, some informational clips. Am I in the wrong class again already? Ah, never mind. Let me go back to the wrong class. I thought that looked weird. Sorry about that. All right, so these are all instructional. The reader, the units. Weirdly, again, Cengage likes to call things by all kinds of different names, and you've probably seen that already. Instead of a chapter, it's a unit, and when we do these assignments, and I'll show you what one looks like, not only do they call it a simulation in one spot, then it changes to another name, so I want to make sure we're all aware of what's going on there. So MindTap units, the preview. So there's some video pieces in here. Right now, although I leave the instructional video up, these live virtual machine labs, for the last 3 years, Cengage has promised me that these are going to be, we can get the entire class in there. And every year I'm disappointed. It's kind of like going to a Husker football game right now, right? Oh, did I make fun of somebody? Too soon? Okay. So, they work great in the summer when there's no students in Cengage, and then as soon as I try to assign one, they break really quickly. So I've pulled them temporarily out. We may introduce some and let you try them, but we'll probably not put any points on those. So here's your reading. This is a review, and in other words, it's actually that same PowerPoint, but it's now inside of a frame. Key terms. So this is just a flashcard. This is a visualization of those OSI models. This is another practice for terms, the crossword puzzle. Now, the crossword puzzle I put in there because it's kind of fun as a great study guide, except it has a pretty high failure rate of wanting to not load. So I've run into it and I thought, well, oh no, we'll use Chrome and it'll always work in, no, it doesn't always work. It's great when it works. I have had some intermittent failure, so I certainly don't assign points to it, but it may be a great use. So I hid this, the live virtual machine labs. Notice it says hidden, because right now we're gonna hide away from this. The lab simulations 1 and 2 you are assigned to do. So quick assist, connect to a remote user, and create a virtual machine. Now, we are going to have some additional virtual machine assignments in here because I really love the idea of how to do this. And if we look at what's going on in the world of servers, that's very, very popular. So this is just another video about showing you how to use MindTap and then the quiz. So the quiz does count. So another instructional video. In fact, that's the live virtual lab. So I'm going to actually do this right now. Chunk. I just made it unavailable for you. We're also going to start Chapter 2, or as Cengage calls them, units. So we're going to start it. So we're going to read it and talk a little bit about it. And there is one lab simulation due. This installs ZenMap and scan your network. So there's a review, so PowerPoints, flashcards, and the crossword puzzle. And then I put some other materials down here. There is another link to the OSI reference model. And again, that might just give you another helpful understanding of it. So what do I need to do this week? Before the 6th, that Monday night, when this class ends. I have 3 lab simulation assignments to do. If I look over here in discussion boards, I have a couple of things I need you to do. I want you to introduce yourself so we all know whether you're on campus or online. And then for week 2 this week, I need you to do this. So at the end of chapter 2, there's a hands-on project, 2-1, tour MDF and IDF data rooms. So I want you to do that assignment. Now, here's one thing that I will tell you about Blackboard just to make life miserable for all of us. If I go in here and I click the reading, you would think that's the one that will lead me to where I need to be. If I click reading, and it's going to pop up and it'll sign me through and it'll take me to that chapter of the book. So in this case, it says, all right, here's all this stuff. This chapter seems to work. So if I go to the bottom and I go hands-on projects, capstone projects, those all show up now. In some cases, when I click just the chapter this way, it doesn't show the end of chapter activities. And I have to go over here to the full book, and I'll make it bigger. And I want to go to the same thing, so I'll go to the table of contents, go to chapter 1. And then there actually will show up there. So if they do not show up from the original link, go to the full book. And I know that's really silly. I'm not sure why that works. Nobody in Cengage can seem to tell me either. But sometimes the very last pieces of the chapters are not displayed when I just go to the direct link. So if you're going in here and I say do assignment, so in this case do assignment, discussion board. So if I say do the hands-on project, project 2-1, tour MDF and IDF data rooms, and it doesn't show up here. So hands-on projects. So there's one. There's the similar thing we're doing to LabSim, so apply troubleshooting. So you'll have to go in and find that one. If it doesn't show up, let me know, and I'll point you to the correct area to go there. All right, so most of you, or a lot of you, have already done these LabSims. Assignments, week 1. So I'm going to launch one here just as a test, make sure it goes through. Life is all beautiful, sort of. They do take a little bit to propagate through. So I'm going to start the assignment. But notice what they call it. So we go from Cengage to MindTap to Lab Simulation. But then, what is it actually called inside of here? Lab Connections. So thank you, Cengage, for driving us completely crazy. So this is VirtualBox. So for all of us, I'm going to have this experiment later on, but especially here on campus, we use VirtualBox a lot, and I'll show you how it works. And we use some other virtualization tools. So this will take you through this step by step by step on how to create a Windows 10 virtual machine. Why would I create a virtual machine for Windows 10 if I'm running Windows 10? What is the advantage of that? What might be an advantage to running a virtual machine?
It's more powerful than your actual computer. Like, you're not running it off your computer, you're running it on the
So
computer.
I'm going to change that a little bit to portability. So I can take that virtual machine that's running and I can move it from one computer to another or to a server. So that's a really good consideration. What about security? If the worst thing that happens, I get a virus on side of one of those virtual images, I shut it down and restart it. And I go back to a point in time that I had before. So that's kind of handy. What if I want to try software and see if it's going to crash my computer? I can put it inside a virtual environment. What if I'm a web designer and I need to test out software that's going to run in Windows 10, Windows 7, on a Linux machine? So it gives me that ability to run all those virtual images to try things. So security. it's kind of an interesting way to run multiple operating systems on one device so that we can do it for testing purposes. We can consolidate hardware. I don't have to have 3 different computers on my desktop. So there's a lot of reasons for it, and we'll go through a lot more of those. All right. So hopefully that clears up anybody's confusion about what is due. Yes, if I go into Cengage, there's a lot of stuff. If you just follow this link, you'll get almost every piece in there. All right. Somewhere down here, we're not going to do all of this, but I want to talk about Chapter 2 and kind of get us on a start. So Chapter 2, so now we're starting to talk about that infrastructure, and there's another term in there that's frightening. That frightening term of documentation. Why do I need to document what's on my computer network? If I'm running a business, it's up and running. Why do I care? As long as it works, right? What if it doesn't work? And you have to call in somebody like OneNet or Five9, and they come down. What do you think an hourly charge for a computer company to come down and start looking at your network and try to fix it is? I agree. Local companies are in it. There's a couple of them. They start at $150 an hour. If you bring in somebody like Five9, OneNet, it's probably $200 to $250 or more an hour. Does that time start when they get to your office? No. Does that time end when they leave your office? No. They get down there, and you don't have any documentation, and they have to start from scratch. Is that going to cost a lot of additional time? So that's one of the values of documentation. And in a lot of cases, if it's well documented, we might be able to figure out what the issue is and fix it long before. So we could do some proactive. All right. So in this whole world of networking and computers, there's all kinds of organizations that provide us some guidance and set out how do we want to install things, how are things built, and that makes some sense. I want my computers, so I want my HP computer to be able to plug into a Cisco router and still work. So there's some standards that organizations have all gotten together and built. And so the TIA, EIA has some of these standards, and we're going to see some IEEE and several others. So 568 is a number you're going to see a lot. You're going to see 568 because that describes structured cabling. So if I say, hey, did you cable those with 568A or B? Oh, well, there's some terminology there. So a couple of things. They've got some like best practices, so you can go out and find out how often do I need to staple a cable to a wall, or how does it need to be supported, or what's maximum cable length, and all those different kinds of things. They give us some guidance on how this should be done. So there are some terms. That we need in here. And so a data room, they may call an IDF. Okay. They may call something an MDF. So where we come in from the internet service provider, we have a spot there. We call it the line of demarcation. That means if you've got Windstream stops their responsibility, and your responsibility as the owner of that building or the owner of that network begins. So that line of demarcation says this is internet service provider, this is me. So in fact, if you go look at your house or your apartment building, there's probably a gray box on the wall, and it'll actually say, Charter cable, Spectrum cable on one side, and say customer premises on the other. And you can open one side up very easily. The other side is usually very locked. So this sets up that idea of where our responsibilities lie. And then some of these, then how do we physically start laying this out? So in this case, there's 3 buildings. Somehow we've got a cable running from one building to another, or there's some communications pathway. And then we have these work areas. So we may also call it horizontal wiring. So if it's going across the floor, that's horizontal. If we're connecting floors, vertical, that seems to. So we may connect floor by floor by floor. So a lot of cases, buildings like this will have a data closet in each floor, and we need to connect them together. So MDF, main distribution frame, again, so that's where our data comes in. That's typically, it'll feed into our data closet if we have one. And then we have individual areas are connected with what we call horizontal wiring. So lots of terminology in here. So that demarc is important. Lets us know who we need to call. Who do we need to deal with? So a data room. Well, in here we have a closet back there. Typically there's some kind of data room in almost every business. Now, when you walk in the door and they're sharing the data room, so there's a couple of servers mounted on the wall, and it's also a broom closet with a faucet in the floor for filling up the mop bucket, we probably need to think about this business and how we can redo that a little bit. But it typically is a space that's enclosed. We have it locked. It's secured in some cases. So racks, so I made a couple of you guys walk in the back. That vertical rack is a standard size. So in that case, the one back there is a 42U rack. It can hold 42 pieces of equipment that are 1U high. Patch panels then, we had back there, and I can show you an example of them. So patch panels connect from cables in the wall to give us a point where we can plug in and out. So this is kind of that conceptual idea. So our internet service provider comes in, our individual data closets all get fed out of this frame, and sometimes we're feeding individual computers. It depends on the building and how the structure is laid out. So that's a patch panel. So on the back side are the wirings coming in, and then these go from that to switches. What that allows us to do then is very quickly change how something is connected. So there's a lot of utility in that, and it makes it a very nice, easy to manage and monitor connection. So what other things might be hiding in there? So now most of our phone systems are based, so a PBX or private branch exchange. So you have phone equipment you need to deal with, and it's probably tucked inside that data closet. So what other things might be in that data closet? What if we're here like on our campus and we provided television service? Now we don't apparently, we were at one point. But if we had a television service on campus, would that be in there probably? So security points, maybe we have alarm relays, all different kinds of things that are in that secured endpoint. So a couple other terms, a wall jack, and we can see them here. In fact, I have a really nice one way up on the ceiling up there. Why is our wall jack way up on the ceiling?
Is it a shelf up there?
No. It looks like it because there was two screws there, and I'm not sure what they were for, but we actually had a wireless access point up there, so it was mounted on the wall. So there was one there, but it's now covered over. So wall jacks. So, and there's standards about how we're going to put those in, and we're going to teach you how to do some of that. So voice over internet protocol. So again, P for protocol. This is the latest trend for phones. Do we need phones for work? Instead of using the conventional landlines, we use something called voice over internet protocol. So it makes their phone call digital, it breaks it into little packets. Well, there's a lot of really powerful things that we can do with it. And one of them that we're not showing in here is in a lot of cases, if you have employees that work from home, they can have a phone that very much functions like their office phone, and you don't know that they're not at the office. And that's a pretty slick technique. Now, we can also use VoIP so that those calls don't necessarily have to be just here in the United States. So we can put our call center in Bangladesh. Why would we do something like that? It's cheaper. We can hire people cheaper in Bangladesh or India. So we put data centers, or we put call centers in a lot of other areas. It's cheap now. We can move phone calls all over the place. So here we have all of our workstations. So those are our computers branching off. We have printers. There's our wall outlet. So again, that's similar to what's up here. But notice there's two different sizes here. And I'm going to tell you that we've kind of moved away from this idea. So in this particular case, there's two different sizes of jacks, aren't there? So the bottom one is an RJ45. And yes, you'll need to know that at some point. You'll memorize it.
The bottom one?
The bottom one is an RJ45. RJ45 has 8 wires on it. Up above is an RJ11, it looks like, which has 6 wires. So is it cheaper to run 6 wires versus 8? Or the cabling is cheaper? But almost nobody uses analog. So now, in most cases, what we do is we have jacks for data, and we'll at least double up the jacks for data. We always need more data jacks in more and new and exciting places. We can never have enough data jacks. And then this is kind of a rack system. So they show a couple of different models. So there are what they call 2-post racks. In other words, there's a post on the left and the right, and everything kind of hangs through. Well, that works great for small stuff that's not very heavy. On the other hand, a 4-post rack has posts front and back, and everything can be supported on some slide rails. Because if, for example, out in the hallway, I'm trying to get rid of this stuff that we haven't yet, that server that we pulled out of there is at least a good 200 pounds. If we hung it off a 2-post, it would be a little sketchy. So they have their purposes. So if I have a bunch of patch panels, those 2-post racks work really nicely. On the other hand, if I've got a bunch of servers, I need the 4-post rack. And so these are enclosed ones. If in the back room, we have just an open 4-post rack. I'm not worried about security in here. This just gives you another layer of security. So not only do you have to have access to the room, you have to then have access to the rack and a key to the rack. So that's what we look like in there. And so if you think about a Google data center, it's just thousands of those cabinets stacked up from one spot to the other. Did you just get food delivered to you?
Yeah, I don't know if you'll play.
Wow. All right. You are the king. I'm going to tell you that. Nice. 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 Wow. Wow. That's like Uber Eats, but not. All right. So let's talk about a couple more things, and we'll retreat out of here. So cables. There's a lot of different kinds of cabling we're going to talk about in here. So a patch cable. A patch cable is typically really short, so usually no more than 14 to 15 feet, although they can be longer. But it has connectors on both ends. So I connect from the wall jack over to my computer. So if you look at these computers here and you look down on the floor, there's all kinds of white cabling. That's patch cables. It goes from here down into the floor. Horizontal cabling is then what's in the floor all the way to the switch. So it's that installed cable, if we want to think about it that way. And then backbone cabling is that cable that supports one location to another. So from our data closet over by the pop machine to the administration building, that's that idea of backbone cabling. So our backbone, we typically will have higher capacity because we've got a lot of things to connect on it. So we have some distance limitations we have to work with. So traditional cabling, and some of this is changing, and not for the better as we start pushing higher and higher speeds. So at gigabit speed, this is the distance limitations we typically have. So altogether, from the workstation, including the patch cable, and including the piece into the data center, we have about 100 meters, or about 330 feet to work with. That's not that very long, is it? When you think about it, that's got to go, it goes down, it goes up the wall, over and around and down. So that's why we tend to have wiring closets all over the place. And sometimes you run into things that happen weirdly. So, I don't think any of you have seen the hospital.
So what's limiting the, I mean, I know that, especially with like higher speeds and stuff, it's limited by the cables, but like
Why do we have the 100-meter limitation? So it has to do the way packets are transmitted and the time. So remember we said earlier that a lot of stuff was connection orientated? So it sends a packet, and if it's much longer than that, it's already thinking, oh, that packet, I haven't got my reception back, and so it's going to send another one, and then you start getting some interesting results with that. You also have signal fade and some other things, but the biggest limitation is actually built in to that idea that these get an acknowledgement packet, and so then you end up with you're sending out extra packets because it can't get returned how long. Now, does it automatically die at 331 feet? No. And we've pushed that before, and sometimes you can get lucky. Now, when we start getting into the 10 gigabits set per second on the copper, we start getting shorter data distances. And in fact, I tend to prefer, if we're going 10 gig or above, I'm an all fiber person. Now, part of that is because I ate oatmeal and Raisin Bran for breakfast. No, I've been involved in fiber for a long time. So, but that distance makes it kind of hard to do things sometimes. We have to do a lot of planning. So in this building, we're lucky that over here by the pop machine, we can actually reach everywhere we need to go within that 330 feet limit. But that's not the case in a lot of places. So most of you have not probably been to the hospital in Fall City. But I use that as a model.
I have.
You actually have?
Yeah.
Why were you in the hospital in Fall City?
It wasn't me.
Oh, you were visiting somebody.
Yeah.
Okay. So at the front of this hospital when you walk in, they decided, from the change in the plans, they decided to go from a regular roof, and we had cable paths drawn in it and identified, to they went to this giant 25-foot open to the ceiling with skylights. All right, so the engineering firm that we had hired and the architecture firm said, oh, I'm going to redraw this data cables. And when we started looking at it again and getting ready for that RFP, that ability, so for those of you that are in project management, we were creating a document that said, we're going to go bid this out. I start measuring it, and all of a sudden, we're at 450, 500-foot cable run. Because instead of re-engineering that, they just said, oh, I'm just going to run it all the way around the hospital from one end to the other. And so we had to come up with some innovative ways to fix that. And what we ended up having to do was we created an extra data closet to get around what they decided to do with that clear story. It was only 900 data cables. It's not that many. But that engineering firm, you'd think they'd know better, right? And we're paying them a huge amount of money. But they redesigned it. It met their criteria, so what do they care? So that distance limitation can get us into trouble. So copper, which is our most common thing, and you guys are all going to get at least in here, get to build one. That copper, you're going to find out, has those distance limitations. It's cheap. It's ubiquitous. It's everywhere. But it's got a few limitations on it. So this is a little further idea of how that would work. So there's our wall outlet, goes to that patch panel, and that patch panel jumps then to our switch and other devices. So that all from switch to computer is about that 100-meter limit. So, and again, it's not going to die at 331 feet, but when you start pushing that edge, you start getting additional errors, and we're going to look at something called Wireshark and actually get to look at it. So this is that copper wiring in a lot of different varieties over here. Ugh. So as the numbers go up, so 5, 5E, 6, 6E, it handles a higher frequency, so you can actually push more data in theory. Now, I can put a lot of data through 5E. 6E introduces a couple of things that are interesting. So even from this picture, you should be able to see the 5 on the far left. I'm kind of in here. On the left, they're twisted together but pretty loosely. If I look at the 6 on the right side of that picture, notice they're twisted very, very tightly. And in fact, in the center is this core. And you can't really see it on here, but it's X-shaped essentially. So each pair of wires has a little corner to land. So it organizes it a little better. Why we do that? Any of you had physics yet? Any of you go, oh, Quaid has. All right. So here's an easy way to think about it. One of the things we want to do is minimize signals from one wire getting onto another wire. That happens, and so if you hold out your arm straight, oh, come on, still, you're looking at it, oh, man. So if you hold out your arms straight like this, notice your arms are side by side, right? So think of those as two wires. Your signal can cross from one wire to the other. The way we avoid that is we want to cross at 90 degrees. So if I now take my arms and I twist them around each other like this, that's the same thing I'm doing with the wire. And the tighter my twist, the closer to that 90 degrees, and the better I can reject foreign signals coming in on that line. So you'll see it. We'll talk a lot more about that. Trust me. There's a sheet over here in the lab about different kinds of measurements and cross connect. So one last piece on here. So we're going to talk about terminations, and part of that is we don't want to leave a bunch of exposed cable even into those patch panels. If we leave cable, typically that means we're not getting those twists very tight, and you lose that advantage for Cat 6 or higher. Even though it's copper, there's what's called a minimum bend radius. In other words, how tight can I bend that cable? When we get to talking about fiber, it's even more important because fiber optic is glass. What happens if you try to bend glass too far? It breaks or cracks. All right. Other things you can do. We've all seen those people that go nuts with a stapler and there's a cable and they're stapling it 37 times in a foot. Well, that can actually lead to some really bad things. So we typically want correct equipment to hang it with. And you want to not have those cables pushed down where they're squishing into the jacket. So we don't want to lay them across the floor or somewhere they're going to get worn. And there's something about here that says plenum rated. Plenum rated. So plenum really means just airspace. Everybody in here likes to breathe, right? Yeah, I hope. But plenum, so in here, when the air conditioning here, notice there's these air returns kind of in here in places. And it just sucks up into the top of this airspace, right? So there's ceiling tiles and it just goes up into this airspace. So that's considered plenum space. It's airspace that you can breathe. Well, we have a lot of cabling up there. The cheaper cabling, well, it typically costs cheaper, but it's just called riser cable. So we could use it in places that are sealed off, but it's got a PVC jacket on it. Well, what happens to PVC when it starts getting hot and starts melting? Off gas, yeah, it starts to give off gases. And one of the gases it gives off is cyanide. Cyanide is very deadly. Probably not the best thing. So the difference in 1,000 feet from non-plenum to plenum rated is about $100. So we go from a couple $100 to $300 for 1,000 feet, somewhere around in there. Not a huge cost increase. I tend to overkill in any place I think could be a plenum or used in that. I don't want to ever kill anybody, so I tend to buy plenum rated for all kinds of stuff. All right, grounding requirements, slack. We're going to talk about all of this stuff then coming up next week and as we enter the last piece of this. So when we come back here on Wednesday, we're going to actually take you guys on a tour. So we're gonna make you guys do some software stuff. So I'm gonna stop this recording for a second.